Welcome to another episode of What About Design? Today we are going to discuss some technical things related to the way computers work. We are going to discuss about images, pixels, some filters, and very interesting things related to design. Now, I am your host, Maria Chernat, and with me as usual is Frank Myong. Thanks for being here with us and helping us.
Hello, it's always a pleasure to be with you. How actually an image is constructed, because usually we do work with pictures. I mean, graphic designers work with pictures, but people usually perceive the image as something solid, something constant. But actually, it's not quite like that, because everything constant in the universe, everything solid, is made by little particles. Or, in the case of the images, it's made by little pixels. So, the first graphic I want to show you is of actually different types of film grain. Because as we know, the silver halide is actually a substance kept in gelatin that is smeared on a paper, makes a layer on a paper, and reacts extremely fast to the light. The smaller is the film grain, the denser is the image, or the quality of the image is higher. That also means that on a very small surface, you could put a big amount of information. If you use a magnifying glass on the surface of your monitor is actually made by a mosaic of little, an older generation TV set was called chromophore. That means the one that creates color. And each chromophore has different value. And in this case, there are 3 chromophores, and one for red, one for green, and one for blue. And the difference of the brightness of these chromophores gives you, and the combination of the brightness of these 3 chromophores gives you the perception of different colors. And as you see here, for example, where the 3 dots for red, blue, and green are at maximum amount, if I zoom out, you will render this as white color.
But when you zoom in, you see the squares. And now what you did here is that you took some of those squares that you see when you zoom in on an image in Photoshop, and you showed us what's behind it, so to speak. So it has color and it has light. This is how the computer creates the image, actually, by these tiny little squares where you have the RGB, red, green, blue colors, and light. This is basically it. And I often tell my students, this is why you need computers that are state of the art to have powerful images, because as much pixels you have, the better the image is, the higher the quality.
The bigger resolution is, we say.
The bigger resolution, and you have higher quality, and it looks very nice. So unfortunately for some of my students that don't have such state-of-the-art computers, Photoshop doesn't work very well.
The monitor and the graphic processor are the ones who are translating it into pixels that can be shown on your screen. When we zoom, you will see the newest Photoshop actually is giving us a map of the pixels, of the actual pixels that are involved in an image. So this is a map of actually already rendered to this color codes that are used in the digital image, but the monitor is the one that is translating this into color dots that are presented on your view screen. So this is only the theory, the mathematical part, and the monitor is doing the practical part. But
Mhm, mhm.
what is, every image actually in Photoshop is represented by different color, different grayscale maps. And if you go to channels, you will actually see the colors. You see red, green, and blue. And I can actually switch off. So,
This is you.
yeah,
This is
actually, you see, this
some
is,
time ago.
no,
I
it
would
was actually
assume.
quite recently, but this is the magic of Photoshop, that it could make me younger.
Okay, okay.
And you see, those are the different plates of colors, and we call that bitmaps, because actually we can work also on them as we can work on layers. And what is the difference between RGB and CMKY? CMKY, oh, sorry, it's mixed, CMYK in English.
Yes.
That we have, I can always convert an image into CMYK, just like that, go in here and convert to smooth color. Actually, nowadays, I mean, like in about maybe 10 years, we don't use that on image anymore because we don't need this. Because when we create some work, we do that in InDesign or in Illustrator and even here. So we export this for print in PDFs. And while exporting, we can click, because there are some color profile systems. I will tell that about that maybe later in, later courses that are used for every image to be constant, and actually they use the color information that is contained in an image, and then it translates it to the printing machine. So this is it gets much easier right now. Like 20 years ago, you have to do this manually. And we don't do that, but I will show you how it looks. So it will ask me, of course, which color system would I use. Doesn't matter. I can use the US web coded swap. I can tell, of course, what that means another time. And this is the CMYK system, which is the actual system of every color print that you see in front of your eyes. In the printing process, every color is represented in rasters. There is a special machine that is called raster image processor, or in abbreviation RIP, which is making every color on plates. Actually, it's projecting, or it's processing it on plates, on metal plates, which are actually the matrices of the printing machine. So every color image is actually printed by 4 colors. So we have cyan, magenta, yellow, and key or black. We say black, but it's key because actually a color image can be created by these 3 colors that we call chroma. But the black actually we call also contour, because that creates the deepness of the image of the print. And it's a completely different system. And the basic part, which is important here, is that every of this color has its unique axis. That's for when you use a magnifying glass and you look at the gazette or every kind of a color image, you will see a pattern which is created by different colors, and it's like a flower or something, when you see it closer. So we have this also channels for each of the colors, and as you see, the black looks like that, because this is the dark, those are the darkest part of the image, actually. And these are, I will show you that actually you will see a correct image even without the black color. But you see, there is a lack of deepness. I mean, it's right, it's okay, but you know, and because my blouse here is black, so if it was white, you couldn't even not, you know, you would not be
Notice.
able even to notice it. Yeah. So, but the black is added just to make the image and to make our presentation full, our practical video. I am obliged to explain the two type of color synthesis or color mixing that we use for RGB, for the monitors, and for the print. As those are additive process and subtractive process. The editing process is the one that is used in monitors and on every devices that produce actually light, that are lighting. And the other subtractive mode that we use is used by newspapers, gazettes, magazines, and everything that is printed in color with 4 pigments. And because of that, they reflect sunlight, and actually what reaches our eye is reflected by the surface of the paper of the color print. And because of that, the color system, the fullness, I mean, the colors that are possible to be printed are much more limited than the colors that we see on a monitor. It is a very often expectation from clients and from even creators or for designers who are not prepared for that, they create something that is bright and colorful, but in printing everything shades. So this is the philosophy in a you know, the very short presentation of the philosophy
colors.
of colors.